Hello students, today we are going to discuss about diazonium salt. Before that, I would like to tell you the field of chemistry. I am Vijay Lakshmi. Please subscribe my channel so whatever I am giving videos that will be updated to your mobile. Hope you can understand my teaching. Let us go to the chapter. Diazonium salt. Diazo means it's a nitrated compound. Nitrogen group will be available. So di means two. Azo means it is a nitrogen compound available. So two nitrogen atoms present in that is diazonium salt. So in this, what are the points we are going to discuss? Stability of diazonium salt, whether it will be stable or not, that one we are going to discuss. Another one, preparation of diazonium salt, which is very important, and naming reaction. In that naming reaction, Sand-Meyer's reaction, Gattermann's reaction, Schemann's reaction, all these reaction we are going to check. So all these reactions involved in reaction involving removal group. Okay, let us discuss all these points. Okay, first one, diazonium salts. Just now I have told about diazonium salts. So what is the general formula of diazonium salt? Means aryl group attached with two number of nitrogen will be 2 along with halogen atom. So if it is halogen atom is available, naturally that will be a salt. So that is what diazonium salt. Di means two nitrogen group combined with aryl group. That means aromatic group attached with that, and along with halogen group is present. That's what we are saying, it is a salt. Okay, now next one, nitrogen triple bond will be available, that you might have known already. Okay, so this is a diazonium group. Diazonium group means N triple bond, N here plus. Why it is plus? Because Cl minus. So this is a what it is, positive charge, and this is negative charge. Combined together you will get a salt. Okay, now some of the few examples we are going to check with that. So this group N2Cl minus, N2Br minus, N2HS4 HSO4 minus, N2BF4 minus. So these are all azo group, that means diazonium salt which is attached with the benzene ring. Okay, let us discuss this. Benzene diazonium chloride. So benzene ring is attached with the diazonium group. Okay, N2Cl, N2 plus Cl minus. Okay, remember that N2Cl means that is a diazo group. Second one, this part you remember this point, this group, what it is? Toluene. Methyl group attached with benzene ring, it is called toluene. So methyl group attached with toluene combined with diazonium group. Diazonium group, what it is? N2 plus with X minus, any halogen group, whether it is chlorine, bromine, iodine, all those things it can occupy with that. So this is orthotoluene diazonium bromide. Ortho, because ortho group it is attached. Okay, next one, this is HSO4 minus. So H2SO4 H2SO4 means H plus HSO4 minus. Okay, though that HSO4 minus ion, so wherever it is a negative electronegative group will be attached to this azo group, that means N2 group. So N2 will be a plus point and this will be a minus point. Hope you got it. So this is what it is, hydrogen sulfate, right? So here benzene diazonium hydrogen sulfate, that's all. It's very easy to name the part. Okay, next one, N2BF4, what it is? Boron fluorate. Okay, so this is combined with azo group. diazonium. So benzene diazonium tetrafluoroborate. Okay, so this is the way we can name that. Okay, now we are going to check the stability of diazonium salts. Before to go this point, I would like to tell you a point wise. The diazonium salts are general formula what it is, ArN2 plus what it is, X minus, that is halogen group, and Ar it is a aryl group only. Why it is aryl group only? Why can't we go for that aliphatic? I'm coming to that next point with that. Okay, now in this Cl minus, see, Cl minus, Br minus, I minus, HSO4 minus, BF4, BF4 minus. So all these electronegative groups can occupy with that diazo group. So that is what diazonium general formula. Okay, now the stability of diazonium salts. See, aliphatic diazonium salts. Just now I told you, no, I will explain to you just now. So aliphatic diazonium salts are unstable, whereas aromatic diazonium salts are stable. That is what we are discussing this point. So aliphatic diazonium salts, for example, CH3N2Cl or C2H5N2Cl, all those things are carbon number 1, 2, 3 till 6. It is a aliphatic we are telling, right? If it is a ring structure, benzene thing we are telling. Okay, suppose if it is aliphatic diazonium salts, if it is available, means it will be unstable. That is what we are not discussing about that point. So diazonium salts means which is attached with the aromatic salts only. So that is called diazonium. Remember that diazonium salts can be attached with the aromatic point. That means aryl group only it will be available. That only will be stable. Okay, remember this point. Next one. Aromatic diazonium salts are stable for short time in solution at room temperature. So what it is, 273 to 278 Kelvin only it will be stable. Very short time it will be stable. So the stability of arene, that means aromatic diazonium ion, can be explained on the basis of resonance. Now we are going to see the resonance. Okay, resonance means what? Imaginary structure. Already you have learnt all those things. Okay, now it's very easiest way. Now for example, benzene, how can you go for resonance? 1 point, see, double bond, 3 double bonds are there. So 1 point it will go there where there is no bond. That means double bond is not there. It will go around. From here it will go, from here it will go. It is like a clockwise rotation. Hope you got it. But when you are going for diazonium salts, it will be anti-clockwise. How come it is possible? See, here diazonium group. See, now benzene ring is there. On the top, N triple bond N. So this is the structural formula of diazonium salt. Okay. Now, in this double bond is there, no? In that one bond already it is plus, it is minus, because lone pair of electron is available here. Okay, now from this one bond goes away from here. When it goes away from here, what happens? In this part it will be a negative, in this part it will be a positive. So what happened? This place will be empty. So this bond it is going to attach over there. From here it is going that side. So automatically you will get a double bond. See here, you are getting a double bond, and this you are getting a minus charge. Now after this bond goes that side, that part will be empty. Now what happened? From here it is going to occupy, because this place is empty now, so automatically it goes from here to this point. So here you will get a positive charge, here you will get a negative. The same way from here it goes, means here you will get a negative, here you will get a positive. Okay, so like this anti-clockwise, from here it rotates. See, from here it comes here, and the same way from here it goes here. Okay, so in this way, see, now the bond it is like this way. Now again the bond it is upside down. So this is the way resonance, and which is very very a stable part. Hope you got it. That's what I have told. It is like anti-clockwise. For benzene resonance and all, it is clockwise. From here it will go, from here it will go. But this part, it is specially, I can tell you for easy way to remember, it is anti-clockwise, because from here it goes automatically, this place is empty. So to fill this from here, it is going there. Okay. At this point, if you remember, means automatically you will come to know very clearly. So this is the resonance structure of diazonium salt. Hope you got it. Okay, now we are going to discuss about the preparation of diazonium salts. Preparation of diazonium salts, that we need nitrous acid. For that, we have to prepare on the spot, okay, because it is unstable. So whenever we require, that time only we can prepare, okay. So sodium nitrate combined with HCl, you are getting nitrous acid along with NaCl. So this nitrous acid I have written in this way, so it will be easy to identify. ONOH, see, 2 oxygen is available, so 2 oxygen is present, hydrogen. So I have written here for a convenient to get a water molecule, for that sake I have written, see, HNO2, I have written in this way, ONOH. In this, we are going to take it aniline as a reactant. So aniline is reacted with nitrous acid along with HCl, cooled HCl at 273 to 278 Kelvin. Okay, the solution of sodium nitrate in water, it is added to that. So benzene diazonium chloride is formed. So this is benzene diazonium chloride is formed. How it is formed? See, in this NH2 is available. No, from here water molecule just bring it out. The same way here also OH is there. Now this OH combined with H plus ion, so automatically this part also it is coming out as a water molecule. So 2 water molecules are coming out. So which is a remaining just as it is, you bring it. So N2 plus Cl minus, which is remaining. So that one attached with what it is. See, here one nitrogen group is available, here one nitrogen group is available. So naturally it is N2, Cl minus, here it is. Okay, hope you got it. So this reaction, it is called diazotization. So what is diazotization? It is aniline is reacted with nitrous acid along with HCl at room temperature 273 to 278 Kelvin, we are getting a diazonium salt. So that diazonium salt's preparation, it is called a diazotization. Suppose if they ask 2 mark question, what is diazotization? That is a preparation of diazonium salts. Aniline is reacted with the nitrous acid along with HCl, you are getting a diazonium salts. Okay, so this equation you can write it. Hope you got it. Okay, in this next one, what we are going to check, it is diazonium salt preparation further steps. That is a naming reaction we are going to check, which is very very important for the exam. Okay, diazonium salts, usually we can, preparation of diazonium salts we can see 2 types, that means 2 ways of preparation. So one, it is reaction involving removal of diazo group. So removal of diazo group is what? Naturally N2, it is a diazo group, so it will be removed from the what it is, diazonium salts. And then reaction involving retention of a diazonium group. So retention of diazonium group, which is N2 group, will be available in the diazonium salts only. So this is actually chemical properties. Chemical properties. Okay, so chemical properties only, diazonium chemical properties only, we are going to check it. Okay, now preparation method is only diazotization. How we are going to prepare the diazonium salts. Only one part is there. And at this part, it is a chemical properties. What are the types, what a reaction is involving. So first one, reaction involving removal of diazo group. Second one, reaction involving retention of diazo group. Okay, now the first one, what we are going to check, it is reaction involving removal of diazo group. So how can we remove the nitrogen group from here? So in this, actually very easy, Sand-Meyers reaction, which is very important question in board exam. Okay, Sand-Meyers reaction, what is the main reactant? It is diazonium salt only we are going to take. So diazonium salt mixed with cuprous chloride Cu2Cl2. Okay, in that HCl you are getting chlorobenzene. See, you are removing this part, diazo group, which is removing. So that is called what it is, Sand-Meyers reaction. Sand-Meyers reaction, or suppose if they ask in different way, how do we get chlorobenzene in reaction involving removal of diazo? How can you remove the diazo group along with Cu2Cl2 along with HCl? So in such a way they may ask the question. So diazonium salts mixed with cuprous chloride, you will get what it is, chlorobenzene and nitroso group, azo group, which is coming out. So it is a removal method. Okay, next one. The second point, which is diazonium salt, it is called diazonium salt. Okay, diazonium salt with cuprous cyanide. In that CuCN but KCN, so it is potassium cyanide. Okay, if it is treated with this part, what we are going to get? Only cyanobenzene. Here also removal method only. So diazo group which is going away, which is removed from that. So that's what I have given, very easy to understand. Removal of diazo group, retention of diazo group. Removal of diazo group, which is coming under Sand-Meyers reaction. So the first point, diazonium salt, it is reacted with what it is. First one, what we have seen, cuprous chloride. The same way chlorobenzene you are getting. Here diazonium salt, which is reacted with cuprous cyanide, you are getting cyanobenzene. Remember that. Next one, Gattermann's reaction. This is also naming reaction, which is very important. Okay, now what is this? This is a diazonium salt. Okay, next, it is treated with copper with HCl. Okay, in this copper with HCl or HB or whatever it is, you are getting what it is, Cl is there, no? So this also, Gattermann's reaction also comes under removal of what it is, azo group. So what you are going to receive? You are receiving the, come on, tell, what is this? Chlorobenzene. Yes, it is correct, chlorobenzene, because you are removing that nitrogen group, which is remaining that you can write it as it is. So what is the name of this? Chlorobenzene. Okay, next, which is remaining N2. That's all. Okay, now, so this is what it is, Gattermann's reaction. Gattermann's reaction also comes under removal of diazo group. So Gattermann's reaction, what is the reactant? It is treated with what it is, copper with HCl or copper with HBr. Remember this, which is going to react with that. That is very important, because in some of the questions I have seen compound A, that means diazonium salt, compound A reacts with cuprous chloride. We are going to receive what it is, or diazonium salt compound A reacts with the CuCl, you are getting dash, or Gattermann's reaction and Sand-Meyers reaction. What is the difference? Like, which are the reactant they are going to react? So that is the way they may ask. So remember that points, which are the reactant which is going to react with the diazonium salt. Okay, next one. See, Schemann's reaction, which is very easy. This also comes under removal of diazo group only. So diazonium salt, this is called what it is? Diazonium salt. Okay, diazonium salts combined with what it is? Hydrogen tetraborate. Okay, in this fluoroboric acid. So this is called what it is? Fluoroboric acid. So fluoroboric acid, it gives fluoroarenes, that is fluorobenzene. Fluorobenzene plus BF3 it is formed. So this is Schemann's reaction. So Schemann's reaction means diazonium salts mixed with HBF4. HBF4 is tetrafluoroborate. Okay, so that is the, another one, fluoroboric acid. Okay, this it is react with diazonium salt, you are getting what it is? Fluorobenzene. So all these points, whatever it is, Schemann's reaction, Gattermann's reaction, Sandmeyer's reaction, all these 3 points which is coming under removal of diazo group. Remember that these naming reaction, all 3 naming reaction comes under diazo group, which is removing part. Okay, remember this point. Next one, see here, directly they have given the name conversion of benzene diazonium chloride to iodobenzene. This is one question. This is not naming reaction. This is a question. How can we get iodobenzene from benzene diazonium chloride? Like that they may ask. So what is this? Naturally you will come to know very well. So this is diazonium chloride, benzene diazonium chloride combined with potassium iodide. So you are getting the same diazo group which is removed. So this is I, which is potassium, iodobenzene. This is called what it is? Iodobenzene, and N2 plus potassium chloride, which is removing. Okay, remember this point, which is very easy. So removal method, azo group which is removing means all these points you can remember. See, now we are going to discuss the conversion points. So diazonium chloride, benzene diazonium chloride convert to iodobenzene. Just now we have seen. Another point, benzene to that means benzene diazonium chloride to benzene. That is a reduction point. Next one, benzene diazonium chloride to phenol and nitrobenzene, coupling reaction. All these points what we are going to discuss under conversion points. So how do we convert benzene diazonium chloride to phenol? How do we convert benzene diazonium chloride to benzene? Like that and all they may ask. So these points we are going to discuss. Finally, we are going to discuss with the importance of diazonium salts in synthesis of aromatic compounds that we are going to discuss. See, benzene diazonium chloride combined with what it is, a reducing agent. It is a mild reducing agent like hypophosphorus acid, H3PO2. Okay, this is called what it is? acid combined with water, you are getting, this is what it is, reduced, because this is a reducing agent what we are going to use. So it is reduced. So from here completely remove and you are getting what it is? Benzene. It is very important question. How do we get benzene from benzene diazonium chloride? So hypophosphorus acid that we are using along with water molecule. So you are getting what it is? Benzene. So this is very important. How do we get benzene from benzene diazonium chloride? Second point. See, this also diazonium chloride, benzene diazonium chloride mixed with ethyl alcohol. You are getting a benzene, again benzene product. Okay, 2 points. Okay, any one they may ask, or direct question. Benzene we are getting through diazonium salts along with what it is, ethyl alcohol. That is the way also they can ask. Okay, now benzene, and here what it is, CH3 CHO, you know very well, that is acetaldehyde. Okay, these are the 2 points. How do we get benzene from diazonium salt? Okay, so this is what it is, a reduction process. Hope you remember this. Next point, the next one, benzene diazonium salt to phenol reduction process. This is also, so benzene diazonium chloride warmed with water. So you are getting what it is, phenol. How do we get a phenol from diazonium salt? Through reduction process. That is the way they may ask the question. It's actually very easy. The direct questions only they will ask. How do we get this? How do we get that? Or compound A which is reacting with this formula, and you are getting compound B. What is this? Like that way they may ask. Okay. The next step, what we are going to receive, it is nitrobenzene. Nitrobenzene preparation, it is 2 steps reaction. First step, we are getting what it is, this product. Okay, first one, wait, let us explain. When the diazonium chloride is treated with fluoroboric acid, so this is fluoroboric acid, you are getting benzene diazonium tetrafluoroborate. So this compound name it is benzene diazonium, same as it is there. Chlorine ion it is not available because it is HCl, it has gone from here. Okay, in this which is this part plus and this is minus, so the fluoroborate which is connected with this part. So this is what it is, benzene diazonium tetrafluoroborate, this point. Okay, now next one, this is reacting with sodium nitrate. So what you are getting, completely it removes this side, and nitro group which is going to attach over there. So nitro, this is called nitrobenzene. This is called what it is, nitrobenzene, and sodium tetrafluoroborate. Okay, that one, and nitrogen group which is available. Hope you got very easy points on the direct question or compound A or B. How do we get, like that way they may ask, especially this part of the question. Hope you remember this. Finally, we are going to discuss about the importance of diazonium salts in the synthesis of aromatic compound. See, diazonium salt which is present only in the benzene ring, that means aromatic ring only it is stable, available. Okay, diazonium salts are important tool in the hands of synthetic organic chemist. The chemical reactions of these salts can be used to prepare compounds like cyanides, nitro compounds, aryl fluorides and iodides. So all these product part we have seen. Thus, the replacement of diazo group by other group is helpful in preparing those substituted aromatic compounds which cannot be prepared by direct substitution in benzene or substituted benzene. Okay, so through that removal of nitro group, that means azo group, through that only we can prepare. Hope you cleared this topic, and which is very basic, very easiest topic. Hope you understand this topic. Next chapter, that means phenols and alcohols, that I am going to take another video. Hope you watch that. Thank you so much for watching.